Hello everyone. Today we are going to study about the design and the formulation with processing problems of the tablets. First, design and formulation. For the formulation of tablets, diluents are usually added, and diluents are the fillers which are designed to make up the required bulk of the tablets when the drug dosage itself is inadequate to produce the bulk. The tablet of the size of the tablet should be usually round for ingestion, and the size is 3 by 16 inch to 1 by 2 inch. Tablets below 3 by 16 inch are difficult for adultery to handle because of its small size, and those which are larger than 1 by 2 inch become difficult to swallow. In the round shape, the weight of the tablet is usually 120 to 700 mg, and for higher weight like 800 mg, oval tablet size shape is more better. The diluents which are added to the tablets must have following properties. The diluent should be non-toxic and should be acceptable to the regulatory agencies in all countries where the product is to be marketed. The diluent should be commercially available at the low cost. It should be acceptable for all types of population, like for diabetic patients, for high blood pressure patients, something like that. Then the diluent should be inert with the ingredients of the tablet. It should be physically and chemically stable, and it should be non-reactive. It should be free from the biologic load. The color should be compatible with the tablet ingredients, and it should have no adverse effect on the bioavailability of the drug. There are few cases in which diluent had issues. For example, for the drug tetracycline and calcium salts, which is usually present in the diluent, these both can reduce the availability of the active ingredient by 50%. Second, amine drugs with the lactose and magnesium stearate, which is usually used as a lubricant, can lead to discoloration and browning. Third, eutectic mixture forming materials when compressed in tablets lead to softening. Eutectic mixtures are when two dry powders are mixed, and when pressure is applied, then it can lead to melting of the products, or it can lead to liquefaction, and hence it can directly lead to softening. Third, dibasic calcium phosphate and calcium sulfate have the advantages of possessing low concentration of the unbound moisture and have a low affinity for atmospheric moisture, so it is good for water sensitive drugs. The list of diluents which are usually added are: first, lactose. The lactose is available in two forms, anhydrous and hydrous. Anhydrous form has no Maillard reaction, which is the reaction which leads to discoloration or browning, and the hydrous one is usually used for wet granulation. The two other forms are 60 to 80 mesh course form of lactose and 80 to 100 mesh course, which is regular. The spread diet lactose is good for direct compression. It also acts as a lubricant and as a disintegrant too. With it, neutral or acid-based lubricant should be used. And with amines or moisture-containing products, it can turn brown due to the formaldehyde which is present in it. Spread dried lactose can be taken as anhydrous lactose, as spread dried lactose can capture the moisture and then can lead to problems. The other diluent used is starch. It is in USP grade 11 to 14% moisture and dried one which has 2 to 4% of moisture. The Star RX 1500 is a free-flowing starch which is directly compressible starch and can be used as a diluent or binder and as disintegrating agent too. It has almost 10% of moisture which can be combined with 5 to 10% of drug and 0.25% of colloidal silicon oxide as flow promoter. The two hydrolyzed forms of the starch are MDEX, which is 90 to 92% dextrose, and Cellutab, which is 3 to 5% of maltose. They are free-flowing, are directly compressible, and can be used as mannitol in the chewable tablets because of their sweetness and smooth feeling in the mouth. The third is dextrose, which is also known as cerulose, which is hydrous and anhydrous form, and can replace some spread dried lactose to reduce the tendency of darkening. Mannitol is the most expensive one, but it has a negative heat of solution. That means when it dissolves, it absorbs heat, due to which it leads to cooling solution. It has slow solubility and it has a pleasant feeling in the mouth. It is used in the chewable tablets for vitamins. It has poor flow and it needs high level of lubricant. Sorbitol is an optical isomer of mannitol and it can be used with mannitol to reduce cost. It is hygroscopic above 65% of humidity. Both have low caloric content and are non-cariogenic. Cariogenic means the products which can lead to tooth decaying. Sucrose. Sucrose is available as sugar tape, dye pack, new tape. Sugar tape is 90 to 93% of sucrose with 7 to 10% of invert sugar. Dye pack is 97% of sucrose with 3% of modified dextrins. And new tape is 95% of sucrose with 4% of invert sugar. And it also has a small amount of corn starch and magnesium stearate. All can be used as directly compressible and can replace mannitol also. The last one is microcrystalline cellulose. It is abyssal. It is directly compressible. Two tablets grade exist, which is pH 101 as powder and pH 102 as granules. It is also a disintegrating agent. The second category of the additives is binders and adhesives. The binders and adhesives are added as dried or as wet to form cohesive granulations. They are first acacia and tragacanth. They are the naturally obtained binders. They can be used in 10 to 25% alone or in combination. They are used best when they are wet, but the quality varies due to the different sources and can have microbial content because they are naturally obtained. Second is gelatin. It is also a natural protein which can be used with acacia. The third is starch paste, which is made by dispersing starch in water, and while heating it converts to dextrin and glucose, which is translucent solution. The sugar binders make hard and brittle tablets, but they are of low cost. The modified polymers like alginates and cellulose derivatives are used for directly compression and for wet granulation also. The example is hydroxypropyl cellulose, which can be used with alcohol to give anhydrous binder. Ethyl cellulose is used only with alcohol and decreased dissolution and disintegration time of tablet. The polyvinyl pyrrolidone is used with water or alcohol both. So HPC for anhydrous, ethyl cellulose with alcohol, only with alcohol, and polyvinyl pyrrolidine with water and alcohol both. Then comes the list of disintegrants. The disintegrants help to break or for the disintegration of the tablet when it comes in contact with the water in the GIT. It draws water, then it swells the tablet, and then it leads to bursting. The disintegrant list is as starch USP, which is 5 to 20% of the tablet weight. The modified starches like Primogel and Explotab are also used in low concentration, which is 1 to 8%. Second is clay like Vigum, HV and bentonite are also used at 10%. They are only used in the color tablets because they give off-white appearance to the tablets. Third is acrysol. It is effective in low concentration. It is internally linked form of sodium carboxymethyl cellulose. The another cross-linked polymer that is available as disintegrant is cross-linked polyvinyl pyrrolidone. Then comes lubricants, anti-adherents and glidants. Lubricants are used to reduce friction between tablet and wall of the dye during tablet ejection. Anti-adherents reduce the stickiness between the granulation or powder to faces of the punch or dye wall. And glidants are used to reduce friction between powder or granules and increase flow. So lubricant is for between tablets and dye wall. Anti-adherents is for granulation or powders versus punches or dye wall. And glidants is to prevent the friction between the granules. Minerals oils were used as all these things as a spray, but it can lead to wet spots. Hence, calcium and magnesium stearates are most common salts, followed by talc, which is used as anti-adherents, glidants. Talc has iron and it should be used carefully. High molecular weight polyethylene glycol can also be used, and certain polymeric surfactants are used for water-soluble substances. The material used as glidants or flow promoter are typically talc at 5% concentration, cornstarch at 5 to 10% concentration, or colloidal silica such as cabosyl, siloid, or aerosyl in 0.25 to 3% concentration. Then comes colors, flavors and sweeteners. FDNC and DNC dyes are used as solutions on granulations. When they are absorbed on hydrous oxide, lakes are formed which are used as dry colors. Means dyes when absorbed on the hydrous oxide gives lakes. For water-soluble dyes, pastel colors show least mottling. Flavors are also used for chewable tablets or mouth-dissolving tablets. They are water-soluble but have less stability. Flavor oils are used in 0.5 to 0.75% concentration. Saccharin is used as a sweetener, which is 500 times sweeter than sucrose, but it has a bitter aftertaste and it is carcinogenic. That means it can lead to cancer. Aspartame is also a sweetener, but it is unstable in moisture. During the tablet formulations, some problems are encountered. The problems are as capping and lamination. Capping is a term which is used to describe the partial or complete separation of top or bottom crowns of the tablet from the main body of the tablet, while lamination is the separation of the tablets in two or more layers. Friability is the best test to determine the capping and lamination. The capping and lamination is due to the deformational properties of the formulation during and immediately following the compression. That means, during compaction, particles undergo sufficient plastic deformation to produce dye-well pressure greater than that can be relieved by the elastic recovery when the punch pressure is removed. Means during compression, the pressure is much more than the pressure which can be relieved when the punches are removed. So, this can lead to a small fracture or crack, and if the excess stress that can initiate fracture is not there, then it can lead to lamination. So this can be reduced by pre-compression, that is, first a small compression force is applied, which is followed by the more compression force, or slow tableting rates and less compression pressure. Deep concave tablets lead to more capping as compared to normal tablets. This is because in the deep concave tablets, the claws are there at the edges of the die, or due to the wearing and tearing of the die, which can pull off the crown of the tablet. A certain amount of moisture or water is often required for the good compaction. A granulation that is too dry tends to cap or laminate more due to the lack of cohesion, and hence materials like hygroscopic materials like sorbitol, methylcellulose, polyethylene glycol 4000 are required. Tiered tablet tool is already explained, as the claws can cap the tablet, and the other is incorrect punch set. During the injection, lower punch should not come, it doesn't come up, and during sweeping, that is when the tablets are swept from the punch, it can lead to capping. Hence the lower punch level should be optimal, it should not be high, not too low. The second problem is picking and sticking. In picking, the tablet surface is picked up by the punch, especially when there is engraving or embossing in the tablets. Small letters can lead to more problems, hence big letters should be designed. In sticking, the material adheres to the die wall, which lead to more force during ejection, and this more force can lead to more wear and tear of the machine due to frictional movement of the punches. To prevent picking and sticking, chromium plating for smooth and non-adherent face should be done on the die and other parts which come in the contact with the tablet. Colloidal silica is often used for polishing and smoothing. Some substances which are low melting substances like stearates can soften during the processing, and hence it can lead to sticking. Hence, to prevent this, first refrigeration of the granules should be done, following by the compression. Third problem is mottling. Mottling is the uneven distribution of the drug. This is due to the different colored ingredients or when dye migrate to the surface during granulation. Here the change in the solvent can be done, or particle size can be reduced for the more even distribution of the particles, and drying temperature should be managed accordingly. Adding powder color is good during blending stage. Third is wet granulation. Wet granulation depends on the granule size and distribution before compression. Variation in the size of the granules can lead to wet variation. For example, if granules are big, then even few granules can differ by the number. Like if there are 2 or 3 difference of the granules, then big wet variation will occur. But for small granules, even if more granules difference is there, then too wet variation will be less, because each granule is less weight. The second reason for wet variation is poor flow. Poor flow can lead to uneven filling of the dye and hence lead to wet variation. Addition of gradient can resolve this problem. Poor flow can also be a result of arcing or bridging and rat holding, which can lead to poor flow. This is arcing and this is rat holding. This happens due to uneven particle size distribution and segregation of the particles while going through the hopper. Poor mixing. If a granule is not properly mixed, then it also can lead to wet variation. Hence, lubricants and glidants should be properly mixed. The other problems are hardness variation, which depends on the dye fill and tablet size, and double impression, that is during pre-compression and when lower punch is free to move, it can leave a mark on the tablet before finally ejecting out the tablet. That is, during pre-compression, first punch goes down, then goes up, and then again goes down due to the final compression, and it can lead to double impression. And when lower punch is free to move, then it can come up 2 or 3 times, which can lead to more than one impression. Hence, it should be properly handled. Please let me know for the correction and stay tuned for the further videos.